guys. So today we're going to be learning how to identify and represent functions. And this is really critical because as you become more mature mathematicians, we're going to get rid of the y and start looking at f of x to represent functions. So remember how like we were talking about like y equals mx plus b and how that was a linear equation and how it was a linear function. Well, we're going to start being more mature and get rid of the y and replace it with f of x. Keep in mind, they're the exact same thing. It's just writing it a different way. It's like writing your name in cursive or writing your name in standard notation, right? They're the exact same thing. It's just a different way to represent it. So essential question today is how can you identify and represent functions? And the important thing, and if you should probably highlight this, I tried to underline it and capitalize it and do what I could to make it stand out. But the important thing to take away from today is that in a function, there is exactly one output or y value for each input or x value. So that just means that every y value, every x value is going to have exactly one y value. And so let's just go ahead and take a second to highlight that because, again, that is important. So exactly one output. Okay. I'm going to make that yellow. I think I can make it yellow so it's like, yes, important. There we go. So in these examples, we're just going to determine if it's a function or not. And so really what I'm checking to see is if every x value has exactly one y value. So if I look, let's see, well, in this first one, 1 goes to 2, so that's good. It's going to only one value. 3 goes to 8, that's good. 7 goes to 6. So notice how that 1 doesn't go to 2 and 6. 1 only goes to 2, and 3 only goes to 8, and 7 only goes to 6. Because they only go to one number, that means that it is a function. So yes, it is a function. I should probably spell it right. It's a function. All right, so let's check the next one. B. So B again, check to make sure that every number goes to exactly one number. So in this case, 5 goes only to 3. So that's good. 8 also goes to 3. And so it's okay that 5 goes to 3 and 8 goes to 3. We just don't want 8 to go to 3 and 1. So again, every input has exactly one output. So then now let's check 4 and 2. Well, 4 only goes to 9. It looks like, yes, it kind of looks like it goes to 1, but it's supposed to go to 9. And 2 only goes to 1. So this one's actually also going to be a function because, again, every input has exactly one output. I should probably be clear. Input is on the left because input is what is going in and output is what comes from it. So see how the arrows are going from one to the other? They go from the input to the output. So let's check C. So C, we want to see if it is a function. So again, we're checking to see if every input has exactly one output. So 0 goes to 1. So that is a function, right? Like that's okay. 0 is going to 1. It only goes to 1, doesn't go to any numbers, so we're good. But notice that 2 goes to 4 and to 5. So because 2 goes to 4 and to 5, this is not a function. Because 2 should only go to one number, but this 2 is double dipping. It's going to 2 different numbers, so not a function. All right, and then D, same thing. We want to make sure that every input has exactly one output. So 5 is going to 9. That looks good. If I follow A, it looks like 8's going to 3, so that's good. But 4 is going to 1 and to 3. So because 4 is going to 1 and to 3, I don't even have to check 2. It's already not going to be a function. Again, hopefully that clears it up for you. Hopefully you can figure out, you can understand that again, if it's a function, then the inputs only has one output or the arrows are only going to one number. But if it's not a function, then it's going to go to 2 different numbers. So the output values, they come from tables and they come from points on the graph. So these are all connected. So really these are x values and these are y values in a table. So we're going to look and now and see if the table represents a function. So again, we're checking to see if every input has exactly one output. So every x has exactly one y. So 5, if I look at this example, 5 goes to 7, that's good. 10 goes to 6, that's good. 15 goes to 15, perfect. 20 goes to 2, and 25 goes to 15. So notice that 15 goes to 15 here, and 25 goes to 15. This is okay because every input has exactly one output. Even though there's the output's repeated, 15 is not going to 15 and to 2. 15 is only going to 15, and 25 is only going to 15. So A is going to represent a function. B, let's take a look at B. So 1 goes to 10, perfect. 5 goes to 8, solid. 4 goes to 6, muy good, muy bueno. But look, 1 goes to 4. So remember, I have 1 as an input here, and 1 went to 10. But now it's telling me 1 goes to 4. That's not okay. 1 can only go to one number because it's an input value. And so this is not going to be a function because 1 goes to 10 and 1 goes to 4. And remember, again, a function has only one output. So this is not a function. Now, this is something I really like. So this graph shows the relationship between the number of hours students spend studying for an exam and the exam grades. And we want to know if it's a function. So again, thinking every input has exactly one output, we're just making sure that every x value has exactly one y value. So what we're going to use is something called a vertical line test. And what the vertical line test is, it just says that you can draw a line, a vertical line, and if it doesn't cross 2 points on one spot, on one line, one vertical line, then it's a function. But if it does, it's not going to be a function. So let me kind of show you what I mean by that. I'm going to use this vertical line. I'm going to make it yellow. And I'm just going to see here. Let's zoom in so you can actually see what we're doing. I'm going to see if it's a function. Well, if I do draw a vertical line here, it only goes through 1 point, so that works. But notice here, if I draw a vertical line, it goes through 2 points. And so vertical is straight up and down. Because the vertical line goes through 2 points, and I'm going to just kind of mark it there, it goes through this point right here and this point right here. This is not going to be a function because the line went through 2 points. If it only went through 1 point all along, then it would be good. But because my vertical line crossed 2 points, it's not a function. And if you look ahead on the graph right here, this is also not going to be, it's not a function here as well because, again, the line goes through 2 points. Even though in all the spaces in between, it's only going to hit 1 point because it hits 2 points on these two vertical lines, it is not going to be a function. And so, not a function. Oops. My goodness, my spelling today is not on point because I still spelled function wrong. 3rd time's the charm. There we go. Not a function because it does not pass the vertical line test. Actually, let's make a note up here. This one's not a function. Because if we say not a function, that's cool. But if you're looking at it later and you forgot this video, it's not a function because 1 goes to 10. And to 4. Perfect. All right. So then now hopefully you can answer the essential question, how can you identify and represent functions?